Lesson 8, applying the sine and cosine laws. So the world's tallest totem pole is located in Victoria, British Columbia. While visiting the park, you decide to calculate the height of the totem pole. So we have the totem pole. So the shadow of the totem pole is 42 meters. The angle of elevation of the ground was 40 meters, and you measured the shadow ran uphill, and the angle the hill was made with the horizontal was 5 degrees. So we have a shadow going uphill, and this is 42 meters long. We also know that because it's a hill, this angle right here, where it's elevated, is 5 degrees. When you have the angle of elevation from the ground to the top of the totem pole, you know that this angle is 40 degrees. So what we're going to do is we want to find the height of the totem pole, which is over here. So we have two triangles. We have this big triangle with our x and the height of the totem pole, and we have this little triangle which makes with the ground. We know this is 5 degrees and this is 40 degrees. We want to figure out, say this is angle A, B, C. We need to figure out some angles in our triangle. So if we're looking at the bottom triangle, we only have one triangle missing. So let's call this D, E, F. Angle D is equal to 180 minus 40 minus 5. And you should get 135. So that means that this angle right here, it's really little, but is right 135. And if you can tell, it makes a straight line with the other triangle. So to find our angle here, angle A, it's going to be 180 minus 135, because we know it makes a straight line, so you should get 45 degrees. So this one is 45 degrees. And we already know the shadow is 42 meters. We also need to find this angle. So if you look, this is a right angle, minus this extra 45 degrees, not 45. So angle B is going to be equal to 90 minus 5, which is 85. So this angle is 85 degrees. So using that, it's easy to find angle C, which would be 180 minus 45 minus 85, which is 50. So now we know all of our angles. Now we just need to find our x. So we're going to use the sine law. So we have x over the sine of 45 is equal to, we know these two, so 42 over the sine of 50. We're going to cross multiply and divide, yes, so times both sides by sine 45. These will cancel. So we have x is equal to 42 sine 45 divided by sine of 50. Type that all into your calculator and you should get 38.8 meters. So the height of the totem pole is 38.8 meters tall. Example 2. Brendan and Diana plan to climb the cliff at Dry Island Buffalo Jump in Alberta. The top of the cliff is point A. So let's try that. We have a cliff and the top of it is point A. And at the bottom of the cliff is point C. Brendan is standing at point B, away from the cliff, and uses a clinometer to find his angle of elevation to the top of the cliff to be 76 degrees. So he looks up to the top and sees that the cliff is at a 76-degree angle. Diana is positioned at point D, away from the cliff. Brendan estimates an angle between the cliff, so between the cliff, himself, and Diana, to be 60 degrees. So from C to B to D is 60 degrees. Diana and Brendan are 60 meters away from each other. Diana estimates the angle between the cliff, herself, and Brendan, so CDB, to be 50 degrees. Determine the height of the cliff. So what we want to do, because this is a right triangle, the ground and the cliff make a perfect right angle. So what we want to find is we want to find this side here so that we can use the triangle to find the height here. So I'm going to call it X and Y. So let's just look at the bottom triangle, DCB. I always like to draw an extra triangle just so I can simplify what I'm looking at. So we have 50 degrees and 60 degrees, and this is 60 meters. We know that angle C is equal to 180 minus 50 minus 60, which is 70 degrees. So we can put that into our diagram. So we know 3 angles and a side, and we want to find side D here. So let's find D. So D over the sine of 50 is equal to, now we know these two sides, so 60 over the sine of 70. Now we're going to cross multiply, so sine of 50 times both sides to cancel. So D is equal to 60 sine of 50 divided by the sine of 70. Type that all into your calculator, and you should get 48.9 meters. So let's put that into our big drawing. So now we just have one right triangle. And when we have right triangles, we can use the primary trigonometric ratios. So this is 48.9. We want to find X, or Y, whatever that, let's call it Y. So from our angle, the side opposite is Y. The side adjacent is 48.9. And we'll remember so, ka, toa. So the side that has an O and an A is our tangent ratio. So we're going to use tangent. So the tan of our angle is equal to the opposite over the adjacent. Our angle is 76 degrees, so tan of 76 is equal to our opposite side, which we don't know, which is Y, over our adjacent side, which is 48.9. To isolate Y, we're going to times both sides by 48.9. These will cancel. So you should type in 48.9 tan 76, and you should get 196.1 meters to be Y. Now, you don't have to use the primary trigonometric ratios. You could also just use the sine law. Either way is fine. If you wanted to do the sine law, I will show you that right now. So we have the big triangle here, A, C, B. We know that this is 90 degrees, this is 76 degrees, so angle A would be 180 minus 90 minus 76, which is 14 degrees. And we know this is 48.9. So we'll set up our ratios. We want to find X. So X over sine of 76 is equal to 48.9 over the sine of 14 times both sides by the sine of 76. And X, type this all into your calculator and you should get the same answer. X is equal to 196.1 meters. So if you're not comfortable using the primary trig ratios, just use the sine law. It always works. Just remember that if it has a square, you know that that's a 90-degree angle.